What's up, everybody? This is Kerry. In this video, I'm going to show you how to tweak the NFL model that we created in the previous video. First thing we're going to do is learn how to scale the features in a model. Next thing we're going to do is remove the novelty data. And finally, we're going to bet all the unders for week 1 and see how that works out. I have some stats for you for this particular tweak here that is going to maybe surprise some of you, maybe not. As I mentioned in my previous video, I'm going to post all of my model picks on Tuesday mornings during the 2024 NFL season. In particular, I'm going to give you a win percentage for each game, who's going to win, who's not, what percentages those are, a spread pick, and a total pick. And from those, I'm going to give you my best bets. I'm not going to make all those picks. We're going to look at the models and see what they say, but the really strong ones we're going to pull out and make our best bets. Here's the code. Now, I'm just going to highlight the differences between this code and the code from the previous video. There's just a few changes here. First of all, in the imports here, all these are the same. The nearest neighbors and NK neighbors classifier are the same. This is new. Local outlier factor. This is the package, the code that's going to remove the novelty data for us. The metrics are the same here, but this is new. From sklearn.pipeline, we're going to import pipeline. This is going to create a sequence of steps when our model trains and when it actually makes predictions. And then finally, from sklearn.preprocessing, import standard scaler. This is the thing that scales the features for us. I'll describe what that does in a later cell here. So let's import our libraries. There we go. This is the same data set as before. And just to show you here, we have the season, the week, the date, the team name, the number of points that the team scored. That's from the team's perspective, whether they were home or not, and the opponent name and points, and then finally the spread and the total. And again, this is closing line numbers. So these are totals and spreads that are right before game time. We're going to add the true total again and the over, under, and push columns. This is exactly like the previous video, so I'm not going to discuss that in detail. I'm also going to sort the values again by season and then by week. And this is where we create the model, and this is where we're going to have the tweaks. DF is, again, the NFL data frame where the team is at home. Again, because we have 2 rows for each game, one for the home team, one for the away team, we're just going to look at the spread and total from the home team's perspective. Because we're betting the total, we only need one of those rows. I just want to make a few comments on the features. You can actually go in here and add your own features, like say EPA or DVOA or QBR. Anything you have, any kind of stats that you want to use in your model, you simply add in the features list. And the same thing down here with the target. You can make that whatever you want to. You can make the target the spread, the under, the over, whatever you want to make it. Down here, we're going to iterate through the last 3 seasons of the NFL, 2021, 22, 2023. We're going to do the same thing here as before, create the Y preds and Y trues, a list of those for each of the seasons. And then we're going to iterate through the 18 weeks of the NFL season. And the training set here is the same. The test set's the same. X train, Y train, X test, Y test are all the same. The model is the same as before, so no changes from the previous video. But here is tweak number 1, where we actually scale the features. We're going to create a pipeline. It's just a sequence of steps that we want our classifier to take when it trains on the data and when it makes predictions. So the first step here is to go through and scale the features. Whatever features we have in that features list, it's going to go through and scale them. Now, scaling means it's going to subtract the mean, that's the average, and divide by the standard deviation. That ensures that every single feature has a mean of 0 and a standard deviation of 1. So this is very important to do whenever you have an algorithm that uses things like distance or gradient boosting or anything like that. Those numbers can get really thrown off if you don't scale them first. This is also very important to do for a neural network. And then the model is the next step. After we scale the features, we're then going to apply the model. And against a K neighbors classifier with N neighbors equals 7. So we have the scalar and then the model. These are the 2 steps that are in our pipeline. That's going to be tweak number 1. So when we create this pipeline, we're assigning it to the variable pipe. So down here, when we train the model, instead of doing the model all by itself, like we did in the previous video, I'm going to say pipe.fit on X train and Y train. So it's going to go through there and scale each of those features for all the training data and then create the model. Now for the second tweak, we want to detect the novelty data. These are the games that are the unseen data. This is in the games that we're trying to predict. And if the games have a spread and total that the training data doesn't have or has very little of, then those are games we're going to throw out. Again, we don't want to make predictions on games where we have very little data that's similar to those games. I'm going to do the same thing here. A second pipeline. The scalar is also important here because this local outlier factor is going to use distances just like k-neighbors. And for this local outlier factor, we say novelty equals true. I've been saying novelty data. This is actually a flag or a parameter that we set for this particular algorithm. Essentially what this does, for each data point that it sees, it looks at that spread in total, that particular point on the chart, and it sees if there's anything around it from the training data. If there's not too much around it, that's called the density, then it'll give it a -1. A +1 for data that is very similar to what it already has in the training set, a -1 for data that it doesn't know. So when it does that, when we call pipe2.fit on xtrain, that's what's going on. Again, I'm not going to go into great details. I'm just going to give you kind of a high level view of what these different functions and algorithms do. I understand that the Python and some of the code here might be pretty advanced stuff here, especially this particular video, but don't worry about it. Just kind of get the overall view here, and then we'll see how the model works. Then when we call predict for this pipeline on our test data, it's going to create a list of 1s and -1s. It's going to be a 1 for any test data that it is familiar with, and a -1 for test data that it doesn't recognize. So that's going to create what I'm going to call test novelty. But what I'm doing next, which is also very common here to remove some values from a data frame or a list or whatever, is create a mask. For this novelty data, if y equals 1, that's a comparison, then that's going to tell me that that is data that it recognizes. I'm going to keep that game. I'm going to make a prediction for that game. If it's a -1, then this is going to be false. So it's going to be a list of trues and falses. So down here where we have x test equals x test brackets mask, y test equals y test bracket mask, this is where we get rid of the games from this particular test set that have -1s from this algorithm. That's where we remove the novelty data. That's tweak number 2. And then finally, the predictions here are going to be predicted from the classifier. This is way up here. This is the original pipeline. And we're going to get the y predictions from that. Finally, tweak number 3. If week equals 1, then I'm going to reset y test because I don't want any of the values there to be removed. And I'm going to create these predictions of all 1s. This is making every single prediction a 1 for the under. In other words, bet all the unders. That's what this code is doing right here. Only if week equals 1. When it's all the other weeks, we're not going to worry about it. But we're going to set y true equals y test and do the accuracy score again here. This is the same thing we did in the previous video. Then we're going to add that to y preds and y trues. Finally, down here, we're going to do the accuracy score for the season, trues and preds, do a classification report, a confusion matrix, just like before. I'm not going to talk about this code. We did it in the previous video, but let's go ahead and run this code with the 3 tweaks here. And as you can see for 2021, week 1 is much better. Down here, we have 55% for the unders. Not bad at all. We have 77 wins and 64 losses for when we predict the unders. And then we have 68.75% for 2022, 58%, really good, 78 wins and 56 losses for the unders. I'm looking at the second column to the right there. And then for 2023, 81.25% for week 1, 62%. And look at this down here, 86 and 53 when it predicts unders, and 60 to 54 when it predicts overs. So this model is actually decent at predicting overs as well, but very good at predicting unders in 2023. Okay, here's where we're going to make the predictions for week 1 of the 2024 season. This is the same as the previous video. We have the same features and target. This time the season is just 2024 and the week is equal to 1. Same training set as before. And I have to look up these values. These might have changed. I did update this about a couple days before this video. It might be changing recently. These are just 5 of the games for week 1 of the 2024 season, which haven't happened yet. At the recording of this video, these games have not been played yet. And this is X new. Here we have the pipeline with the scalar and the model, just as we have above. We're going to fit it to the training set. Here we have the second pipeline for the novelty detection. We fit that and then do the prediction for the X new features. That is again, the games that are coming up in week 1 of 2024. We create the mask and this time we say X new equals X new mask. We don't worry about X or Y test here or Y new. there is no why new. These games have not been played. So nothing to compare it to yet. I mean, these are where we make predictions for the future. Here are the predictions, Y pred. And now again, if week equals 1, we're going to simply set Y pred to be all ones. So you can kind of see what's going to happen here. And same thing here, we're going to add this to our data frame. And lo and behold, here are our predictions for week 1 of the 2024 season from this model, all unders. So this is it for this video when it comes to the tweaks. But I want to say a little bit more about betting all unders. I've bet all unders for week 1. All 16 games I bet under. And if you want to see why, there's a little bit more information down here. I'm going to do a little piece of code here where I grab the seasons and the week 1s. I look at all the unders, and then I print out how many unders we have, the under count divided by 16, and see how many we have. And this is what we have for the 3 seasons. The last 3 seasons, in week 1, 56.25% in 2021, 9 of 6 games went under. For 2022, 68.75%, 11 of 16 games went under. And last year in 2023, 81.25% unders, 13 of 16 went under. It's okay to bet overs, maybe, yeah, sure, but look at these percentages. If you're going to bet an over on a game, then you're basically going against these percentages because you're basically in the minority class there. The minority class meaning that there's fewer overs than there are unders. So that is something that I would not bet on because it simply doesn't happen enough. I know it might seem kind of strange to bet all unders, but when you think about what you would do if you did bet an over, you're really going to have to be a really daggone good at pinpointing those overs to get the minority overs correct. So I'd rather just simply bet all unders and let it ride. And that's what I'm doing. So here is a cumulative version of the KNC 7 model tweaks here. This is the original model right here. This is how it did on betting unders. It won 61 and lost 57 in 2021 for a 54.8% win rate. In particular, I'm going to show the ROI, that's a return on investment, assuming the negative 110 juice. This is not a hard thing to calculate, but 4.5% in 2021 actually was best among all the different versions of this model. In 2022 is 75 and 59 for 56% win rate and 6.9% ROI. And in 2023 it was 86 and 58 for a 59.7% win rate and a 14% ROI. Overall, what I'm going to show you here is the total. For the last 3 NFL seasons, this model went 230, 174 for a 56.9% win rate and an 8.7% ROI. Now, this is the chart of these win rates down here. This is 2021, 2022, 2023 for the original model right above it. This is what happens when we scale it. Now, compare this to the original. There's one more win and the same number of losses. Differently here. So this is actually slightly better than the previous model. When we scale the model and then remove the novelty data, that removes the games that we don't want to bet on here. It has fewer wins because it removes games from the potential bets here, but it also has 7 fewer losses. Overall, it was 57.2% win rate for 9.2% ROI. And look at the increase here. It actually goes up here, which is what we want to see. And then finally, when we throw in the week 1 unders, we bet under for week 1 in each of these 3 seasons. This model is 241, 173 for a 58.2% win rate, 11%, 18%, and overall 11% ROI over the last 3 seasons. So here is the bar chart for that. And I really like the fact that this is increasing from one year to the next. I love the fact that the model is doing better and better each and every year. NFL season's right around the corner. I can't wait. See you in the next video.